In July of 2022, the first images taken by the James Webb Space Telescope began to flood in, to great and continuing success. And there have been a number of surprises since it first began its mission, which is primarily to look at the early universe through the depths of space-time, and see how things were when the first galaxies and earliest stars were still forming. There were plenty of expected things observed, but also some surprises, including one enigmatic group of objects known as little red dots, and are so far rather hard to explain and represent a completely new mystery in cosmology. Almost every new image tailored towards these kinds of deep space observations showed the new phenomenon that look like tiny red points of light, that are very bright for what they are, which are point-like, and compact and very red. These little red dots, or LRDs, are very numerous. Webb sees them everywhere in deep space observations, and they were thought to date to about 600 million years after the Big Bang, but that may not entirely be the case, more on that in a bit. This means that the light they emitted back then took most of the life of the universe to get to us, deeply reddening the light. But there is a further mystery. These are no longer in the modern universe as far as we can tell, and they basically shut off for the most part by about 1.5 billion years after the Big Bang, though that is complicated. A few hypotheses have surfaced since the discovery of these objects. The first is that they might be compact galaxies with supermassive black holes affecting material at their centers. This could mean that they represent a snapshot of a supermassive black hole in a galaxy at a very early stage in its evolution. The problem is, these objects are extremely compact, seemingly too much so for such a galaxy. They could also be dust-ridden early galaxies in a stage of starburst formation of stars, but again, the compactness poses an issue, so ultimately, at this point, no one actually knows what these are. If they are black holes of some flavor, there may be a lot of things to learn from observations of them. If they are early supermassive black holes at the centers of young galaxies, it might be revealed how they form and evolve and seemingly grow so fast, another discovery by Webb, and even might give an insight into how galaxy clusters form and how galaxies, at least some of them, seem to mature so rapidly in the early universe. They might even give information on the enigmatic direct collapse black holes that occur without a supernova. There may be two or more types of these. One seemingly recently has been confirmed, that of a star of a certain mass that collapses without a supernova explosion directly into a black hole. But here it's different because these red dot black holes may never have represented a star exploding, but instead a direct catastrophic collapse of gas. But here there was so much gas in the formation of some early galaxies that the process didn't form a star at all, but directly went black hole. Or maybe it did form a star, leading to a bizarre scenario. Here there is a weirder option hiding within physics. About 20 years ago, there was a prediction that at least in the early universe, there may have been objects known as quasi-stars, also known as black hole stars. This is a strange one. It's not quite a star, but not quite a black hole either. They are hypothetical stars of a mass between 1,000 and 10,000 times that of the Sun, that were powered in the early universe not by nuclear fusion, but instead by material falling into a central black hole located inside the stars. These would have shone very brightly and have been compact, as the little red dots are doing, but would have ended life by collapsing into the black hole at their center, causing it to grow into a supermassive black hole. Regardless, this would mean that we're seeing a totally new astrophysical phenomenon with the little red dots, though there remain skeptics of the quasi-star idea in the scientific community, but the possibility is gaining some ground. This sort of thing has happened in astronomy before. The discovery of quasars in the 1960s was out of left field effectively, and took many years for astrophysicists to find a satisfactory explanation of just what they were, and how they managed to exist. Quasars were not predicted, like the quasi-stars, but were found by surprise, like the little red dots. Now we know about active galactic nuclei regarding quasars, but back then they were a mystery much like the little red dots. So the dots appear very red, and that typically means redshift in this context, meaning that these objects are exceedingly old, which allows for the estimate of their age. Basically what happens is the expansion of the universe stretches their frequency and reddens their light as the photons travel across the universe, suggesting great distance. And by virtue of looking into space means looking back in time, because light takes time to travel. But the dots are actually a bit too red, leading scientists to believe that the red dots are inherently red. In other words, the light started out red and got redder with distance. This is probably a phenomenon of dust blocking out other wavelengths of light coming from these objects. So whatever these are, they are in a dusty environment, or one with a lot of gas as well. It's worth noting why it took until now to see these objects. So James Webb is an infrared telescope. Red light is its specialty, and it's very good at the mid-infrared frequencies of these objects. But with a telescope like the Hubble Space Telescope, which works mostly in visible light, it can't actually see them. They're too red. Webb is not the first infrared telescope in space, but it is the most powerful, and it took that level of sensitivity to see these objects. But now that we have that, we're seeing them all over. One of the problems with the little red dots is that normally the best explanation for something like this is star formation. Literally the formation of billions of stars essentially at once, and a starburst might produce something like this, due to a technical phenomenon with the light known as a Balmer break. But the dots are too small for billions of stars to be there. And these dots are so old that they simply did not have the time required to form that many stars. One clue, however, came in the discovery that the dots appear to be spinning, often quite rapidly. This would most likely point to the involvement of a black hole accreting material. The problem is that usually with that kind of environment comes X-ray emissions, which is a hallmark of black holes, a textbook one, yet they aren't there with these objects. They also do not resemble active galactic nuclei in character. At the very least, there's dust or gas here, and whatever is being observed may be heavily shrouded, masking some of its characteristics. But again, no one yet knows. It may actually be, and the research to some degree is moving in this direction, that it may be a combination of factors, but still centered around the activity of some kind of black hole. Interestingly, when you pack a huge amount of stars into a very small area, in this case extremely small, just a fraction the size of our galaxy, you would get stellar collisions, and the result of that ultimately is black hole formation completely separate from the direct collapsing of gas. There should be signatures of that, but there isn't. Rather, this looks like a massive black hole being shrouded in a dust or gas cloud, or at least some modeling shows that it would be consistent with that. The mystery deepened further in 2023 when a study known as RUBIES used JWST to detect 40 new little red dots, including one known as the Cliff, which shows a particularly strong Balmer break signal, and upon closer analysis showed almost no ultraviolet emissions, but a sudden spike for lower frequencies. Short answer, galaxies do not show this specific feature, and neither do normal black holes. But it does once again support the idea of a black hole surrounded by huge amounts of gas, which again, perhaps oddly, supports the idea of a quasi-star of some type. Basically, the model here shows that a massive star first forms, collapses into a black hole, but does not blow its outer layers into space. Rather, the quasi-star forms from the outer layer around the internal black hole core. In a paper by Mitchell, Begelman, and colleagues, they propose that the little red dots are in fact quasi-stars, link in the description below. If this is the case, this is one of those instances in science where a rather exotic and hypothetical object is conceptually advanced, only to be found 20 years later through observation. If that is indeed what the little red dots represent, this is still cutting-edge astrophysics, and the playing field for this may look very different in a year or two. But it's also been advanced that these are just dusty, regular supermassive black holes in their infancy, and that this actually just represents a very short stage in supermassive black hole formation in the early universe. Presumably, however, not for the smaller black holes that we see appearing today. But there is another active mystery here. In November of last year, it was announced that Webb had studied a galaxy known as Virgil, which at first glance looks like a normal galaxy as it was about 800 million years after the Big Bang. But when examined with JWST's MIRI infrared instrument, it showed the presence of a reddish supermassive black hole at the center that's too big for this galaxy at its stage of evolution. This means that we may not understand galaxy formation and early black hole growth as well as we thought we did, which in turn opens up avenues for explanations for little red dots that we may not currently have thought of yet in this new paradigm, that our ideas of the formation of supermassive black holes in galaxy evolution may be off. There's also been recent evidence of younger little red dots that may be as close as 1 billion light years away, showing that maybe these things were showing up much later than previously thought. There's also evidence through gravitational lensing and legacy sky surveys that seems to show that the little red dots change somewhat rapidly on short timescales, in this case just 130 years. There's also the question of the role of dark matter in the evolution of these objects, and in galaxies in general, as dark matter halos seem to rotate, but may do so at different rates, which should affect how galaxy structures form. It's also still an open question whether all little red dots are actually the same thing, or several different astrophysical phenomena that at this stage may appear to be the same, but with more data might turn out to be a mixed bag of similar phenomena. It's that early in the game for these objects that such a thing isn't yet constrained. One thing is clear, this is one of the biggest and most mysterious discoveries by JWST so far, and that telescope has its work cut out for it since it represents one of the few ways we have right now for even studying these objects. But more data will shed light on these phenomena as we go along. Thanks for listening. I'm futurist and science fiction author John Michael Godier, currently worried about the little red dots. They remind me of laser pointers, and yes, they have our attention and we're chasing them intently. Very questionable, the universe. And be sure to check out my books at your favorite online book retailer and subscribe to my channel for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.